Okay, hello everyone. I welcomes to all in our lecture series on special integrals, and we are discussing gamma and beta function. In our last class, we have been discussed about beta function. We discussed the definition of the beta function. Then we have been discussed symmetry property of beta function, that is your beta pq equal to beta qp, uh, and also we have been proved that property. Then we discussed different forms or representations of beta function. Here we discussed this one is your first one form, uh, this is another form, uh, and this is your trigonometric form. Three forms we have been discussed. Then we discussed properties of beta function, uh, symmetry property and relation between beta and gamma function. This much we have been discussed. Okay, uh, in this class we are going to discuss some important questions on beta function. See, uh, here in this class we are going to discuss questions uh, based upon, सी बेस्ड अपॉन डेफिनेशन, डेफिनेशन के ऊपर क्या क्वेश्चन हो सकता है उसको डिस्कशन करेंगे. देन वी आर गोइंग टू डिस्कस द क्वेश्चन विच विल बी बेस्ड अपॉन फॉर्म दिस फॉर्म दिस फॉर्म एंड दिस ट्रिगोनोमेट्रिक फॉर्म. दैट मीन्स ट्रिगोनोमेट्रिक फॉर्म को यूज करते हुए कैसे क्वेश्चन हो सकता है उसको डिस्कशन करेंगे. उसके बाद ये जो प्रॉपर्टी है ना, रिलेशन बिटवीन बीटा एंड गामा फंक्शन, ये जो प्रॉपर्टी है बीटा पी क्यू इक्वल टू गामा पी इंटू गामा क्यू बाय गामा पी प्लस क्यू, इसको ले करके और ये जो सिमेट्रिक प्रॉपर्टी, इन दोनों प्रॉपर्टी को लेके हम क्वेश्चन डिस्कशन करेंगे. ठीक है. सो फर्स्ट क्वेश्चन इज दिस वन. Question number 1, we have to evaluate this integral, that is your 0 to 1 x to the power p into 1 minus 1 minus x to the power q to the power t dx. Okay, this question based upon the definition of beta function. Now to evaluate this question, let us consider x to the power q is equal to y. So that implies x कितना हो जाएगा, x will be equal to y to the power 1 by q, right? Here that implies if I am going to differentiate, then it will be q into x to the power q minus 1 dx will be equal to dy, right? That implies dx will be equal to 1 by q into dy by x to the power q minus 1, right? Or we can write this one, dx will be equal to, here I'm going to write dx, that implies dx will be equal to, इसको हम क्या लिख सकते हैं, 1 by q into, here you can see x to the power q minus 1 is in the denominator. अगर मैं उसको न्यूमरेटर को लूँ तो ये कितना हो जाएगा, x to the power 1 minus q into dy. Then that implies dx will be equal to 1 by q into, here instead of x I can write y to the power 1 by q. Then ये कितना हो जाएगा, y to the power 1 by q minus 1 by q minus 1 dy. Here you can see, if I'm going to substitute over here, instead of x y to the power q, already 1 minus q is there, so it will be y to the power, ये हो जाएगा 1 by q, ये हो जाएगा minus 1. Same thing I have written over here. Okay, now we are going to check the new limit. Okay, here we consider that x to the power q equal to y, or y equal to x to the power q, that we considered. So the lower limit of this integral is your 0, upper is your 1. So when x equal to 0, then y also will be equal to 0, because x to the power anything will be x to the power, or 0 to the power anything will be 0. Likewise when x equal to 1, then y also will be equal to 1. So the new limit also will be 0 to 1. Now we are going to substitute these results, that is your, instead of x we have to substitute y to the power 1 by q, dx, instead of dx we are going to substitute this much, and limit we are going to substitute 0 to 1 in the given integration or integral, whatever given in the question, then what we can get. So here I am going to write, by substituting the above values in the given integral we get. By substituting the above values in the given integral, what we can get, here you can see the limit is not going to be changed. The limit will be 0 to 1. Okay, here you can see instead of x we have to put y to the power 1 by q. Already p is there, so it will be y to the power p by q into 1 minus here you can see here x, instead of x we have to put y to the power 1 by q. Already power q is there, so it will be y to the power 1. That means 1 minus y to the power t. ये तो t था, t is there, so t will be written as such into dx. dx वैल्यू कितना है, इतना, यहाँ पे लिख दो 1 by q into y to the power 1 by q minus 1 into dy. So this integral is with respect to y. So here 1 by q is a constant taken outside of this integration. Now integration 0 to 1. Here y to the power p by q. Here y to the power 1 by q minus 1. I am going to write the power, adding the power of the y. Then it will be p by q plus 1 by q minus 1. Right, y to the power this much into 1 minus y to the power t into dy. Right, okay. This one also can be written as 1 by q 0 to 1 y to the power. Here I am going to add these two terms only, so it will be p plus 1 by q, p plus 1 by q minus 1, and here this one 1 minus y to the power t. This t can be written as like this, t plus 1 minus 1 into dy. Let this is your equation number 1. Okay, now consider Euler's first integral. Euler's first integral, or as per the definition of a beta function, as per the definition of beta function, beta pq is nothing but 0 to 1, integration limit 0 to 1, x to the power p minus 1 into 1 minus x to the power q minus 1 dx. These things already we have been discussed. Here I am going to show you. Initially we discussed this one. Here as per the definition, beta pq equal to this much, x to the power p minus 1 into 1 minus x to the power q minus 1, and this is also called as Euler's first integral. Right, now I am going to compare this one, this Euler's first integral. इसको एक मैं इक्वेशन नंबर दे देता हूँ, इक्वेशन नंबर 2. You just compare equation number 1 and 2. By comparing equation 1 and 2, we can write what we can write. We can write here I am going to compare this one first. See here, instead of x y is there, instead of p, here p plus 1 by q is there, here p minus 1, here p plus 1 by q minus 1 is there, and here instead of q p plus 1 is there, and integration is your 0 to 1, 0 to 1. So if I am going to compare equation number 2 and equation number 1, then equation number 1, what we can write, here I am going to write we can write the equation number 1 as ऐसे लिख देते हैं, ठीक है. We can write the equation number 1 as what, that implies 1 by q integration 0 to 1 y to the power p plus 1 by q minus 1 into 1 minus y to the power t plus 1 minus 1 dy will be equal to 1 by q, वो तो है. This integral is nothing but beta p plus 1 by q t plus 1. Okay. By comparing equation number 1 and 2, we found what? Instead of q, we can write p plus 1, what I have written over here. Instead of p, we can write p plus 1 by q, right? Okay. That implies, इसको भी हम क्या लिख सकते हैं, देखो. That implies, अच्छा बाद में लिख देते हैं, ये थोड़ा बड़ा है, इसको इज इक्वल टू यहीं पे सॉल्व कर देते हैं. तो इज इक्वल टू ये क्या होगा, 1 बाय क्यू. दिस वन कैन बी रिटन एज गामा p plus 1 by q into gamma t plus 1 whole divided by gamma p plus 1 by q plus t plus 1 by using one of the property of the gamma function. This one यहाँ पे लिख दो, by using the relation between, by using relation between beta and gamma function, that we know beta pq equal to gamma p into gamma q by gamma p plus q. Okay, so here instead of p, this one p plus 1 by q, instead of q t plus 1 is there. So if I'm going to transform beta to gamma function, then gamma p, that is nothing but gamma p plus 1 by q, gamma q, here it will be gamma t plus 1 by gamma p plus 1 plus t plus 1, right? Then further, if we are going to simplify this one, 1 by q is there, here gamma p plus 1 by q, and this one is nothing but your p factorial whole divided by this one can be written as p plus 1 by q plus t factorial, because 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 we know that gamma n plus 1 equal to n gamma n. This is the this is one of the property of the gamma function. So here you can see gamma t plus 1 can be written as t factorial. If gamma n plus 1 is your n gamma n, or we can write this one is your n factorial. Okay, then this gamma t plus 1 can be written as t factorial. Here gamma p plus 1 plus t, this much term, then plus 1, so can be written as this one p plus 1 by q plus t factorial. So finally we found this one, this answer of this question. So evaluation of this integral, finally I'm going to write. That implies what we found, that the integration of 0 to infinity 0 to 1 x to the power p x to the power p into 1 minus x to the power q to the power t dx, इतना तो था ना, x to the power p 1 minus x to the power q to the power t dx. What we found finally, 1 by q into gamma p plus 1 by q into t factorial whole divided by p plus 1 by q plus t factorial. You just remember this expression. By using this expression, we can evaluate a given integral directly. How? Here you can see I'm going to use this above expression and we can find the value of the integral directly. How? Suppose here I'm going to show you. Suppose one integration given like this, we have to evaluate 0 to 1 x to the power 3 into 1 minus x to the 2 whole to the power 6 dx, ऐसा एक इंटीग्रेशन दिया गया है एग्जाम में, एंड फॉर 2 marks question it has been given. Okay, 2 mark or 1 mark. We have to use direct this expression. Here if I'm going to compare this integral and this integral, this integral and this integral, here p, here if I'm going to compare, then here the so-called p will be equal to 3, and here q is nothing but 2, q is equal to 2, and t is your 6. So the integral value of this question will be how much? That implies this integral value, this integral value, this integral value will be how much? 1 by q, q means 2, 1 by q into gamma p plus 1 by q. Here p is your 3 plus 1 by 2, 3 plus 1 by 2 into t factorial. T factorial means 6 factorial whole divided by p plus 1 by q. P plus 1 by q, that means your uh, 3 plus 1 by 2 plus t, that is your 6 whole factorial. So what will the answer? Here you can see is equal to 1 by 2. Here gamma 3 plus 1 by 2, that will be gamma 2 into 6 factorial divided by this one. Here this will be 3 plus 1, 2 plus 6 is your 8 factorial. So finally what we can found? 1 by 2, gamma 2 is your 1. Okay, 6 factorial by 8 factorial. That means here we can get the denominator. Here 8 factorial is nothing but what? 8 into 7 into 6 factorial. So 6 factorial got cancelled, and we can found 8 into 7. So finally how much we can found? The answer will be 8 into 35 into 2, 70. This will be the answer. So directly we can evaluate the answer uh, for this type of integral by using this expression. Okay, so I suggest to all of you that you just remember this one. Remember. Okay, now we are going to go for our next question. Our next question, that is your question number 2, is this one. We have to prove beta pq is equal to 0 to 1 integration limits x to the power p minus 1 plus x to the power q minus 1 by 1 plus x to the power p plus q dx. Okay, this proof can be done with the help of the first form of a beta function. Here I am going to show you. Also we have been proved that one in our last class. This one, this is by using this form of beta function we are going to prove the question number 2. Okay, first I am going to write this form: beta pq equal to 0 to infinity t to the power p minus 1 by 1 plus t to the power p plus q dt. Okay, okay, here I am going to write, we know that previously we know that here proof starts. Previously we know that beta pq also can be represented as 0 to infinity t to the power p minus 1 by 1 plus t to the power p plus q dt. Let this is your equation number 1. Okay, now this integral, that is your equation number 1, can be rewrite as this one: beta pq is equal to, here I am going to segregate the limit, integration limit, 0 to 1 t to the power p minus 1 by 1 plus t to the power p plus q dt. Then another integration limit will be 1 to infinite t to the power p minus 1 by 1 plus t to the power p plus q dt. Okay, okay, let this is your equation number 2. So in equation number 2 we have two integrals, this one and this one. Let this is your integral I1, this is I2 integral. Now we are going to modify this integral I2, then we are going to substitute in this equation number 2. You just write now modify I2 by considering as instead of t equal to 1 by x, that implies dt कितना हो जाएगा -1 by x square dx. if t equal to 1 by x, then x कितना होगा 1 by t. okay, now consider the न्यू लिमिट. नया लिमिट जो होगा वो कितना होगा भाई, देखो यहाँ पे वी कंसिडर इंस्टेड ऑफ टी 1 बाई एक्स और एक्स इक्वल टू 1 बाई टी. सो फॉर टी इक्वल टू 1, बिकॉज लोअर लिमिट कितना है 1. इफ टी इक्वल टू 1, देन x will be equal to here, if I am going to put 1, then x will be 1. फॉर t इक्वल टू हायर लिमिट कितना है, हायर लिमिट है इन्फानाइट. अगर इन्फानाइट में लूँ देन x कितना हो जाएगा, x will be 0, because t if I am going to put 0, sorry infinite, then x will be 0. so नया लिमिट कितना हो गया 1 to 0. okay, so I2 will be hence I2 will be, यहाँ पे मैं लिखता हूँ देखो कितना होगा, इंटीग्रेशन लिमिट था कितना 1 टू इन्फानाइट, नया लिमिट हुआ कितना 1 to 0. 1 to 0 हुआ नया लिमिट. इंस्टेड ऑफ t वी हैव टू राइट 1 by x, 1 by x to the power p minus 1, right, whole divided by here 1 plus t to the power p plus q. so here 1 plus t means 1 by x, we have to substitute p plus q. okay, into dt we have to substitute 1 by x square dx, right. now is equal to here minus sign is there. अगर minus sign will be interact with this integration, then the limit will be exchanged or will be altered. so I am going to omit this minus sign and I am going to exchange the limit. so it will be 0 to 1, and this is your 1 by x to the power p minus 1, okay, into 1 by here 1 plus 1 by x can be written as x plus 1 by x to the power p plus q into 1 by x square dx, right, is equal to 0 to 1. लिमिट तो है. अभी मैं x 1 by x को x लिखता हूं, तो इसका पावर कितना हो जाएगा -1. सो x टू द पावर माइनस ऑफ p minus 1 ये हो जाएगा. अभी ये x इधर है, ये x ऊपर जाएगा तो कितना हो जाएगा x टू द पावर p plus q by 1 plus x plus 1 can be written as 1 plus x to the power p plus q. Here this x will be moved to the numerator, it will be x to the power -2 dx. now we are going to add all the power of x. how much we can get, 0 to 1, limit x to the power, here x to the power minus p plus 1, here plus p plus q, here -2. okay, into 1 by 1 plus x to the power p plus q dx is equal to here minus p plus p got cancel. Here minus 2 plus 1 will be minus 1. So 0 to 1 x to the power q minus 1, q minus 1 divided by 1 plus x to the power p plus q dx. So this much value किसका है, I2 का है. So that implies we found I2 equal to this much. Let this is your equation number 3. Now I am going to substitute this I2 value in equation number 1. What we can found? Put I2 in equation number 2. We get what we can get here. Equation number 2 was this much. So beta PQ will be I1 will be written as such. So that implies beta PQ will be equal to 0 to ये कितना है 0 to 1 t to the power p minus 1 1 plus t to the power p plus q dt, right. Beta PQ will be equal to 0 to 1 t to the power p minus 1 divided by 1 plus t to the power p plus q dt, ओके, प्लस I2 का वैल्यू तो यहाँ पे हमको मिला है, इधर मैं डायरेक्ट यहाँ पे लिख देता हूँ इंस्टेड ऑफ दिस वन. 0 to 1 x to the power q minus 1 by 1 plus x to the power p plus q dx. Okay, we know that this t, p, q are dummy symbols. We know, इसको इक्वेशन नंबर 4 दे दो. Consider this is your equation number 4. Okay, we know that p, q, x, t are dummy symbols. Dummy symbols. So here instead of x we can write y, we can write z. T also can be written as y, z. Instead of p we can write m, n. Okay, so if it is so, then equation number 4 में instead of t we can consider x. Okay, in the first integral. Then here you have to write, then consider t equal to x in equation number 4. That means in the first integral of the equation number 4 we are going to substitute instead of t equal to x, because x is a dummy symbol. So if t equal to x, that implies dt can be substituted as dx. Here you can write, then consider t equal to x or dt equal to dx and कर दो, and चलो अच्छी तरह से लिख देता हूँ, and और इसको ब्रैकेट में रख दो, ठीक है. Consider t equal to x and dt equal to dx in equation number 4. We get what we can get. That implies beta PQ will be equal to 0 to 1. Instead of t, x we have been written to the power p minus 1, 1 plus x to the power p plus q dx. Instead of dt, dx I have been written. Then 0 to 1 x to the power q minus 1, 1 plus x to the power p plus q dx. Okay, I think we have been proved here. इतना हमको प्रूव करना चाहिए था ना. सी ऑलरेडी वी हैव बीन प्रूव्ड हियर. इंटीग्रेशन 0 to 1 है, dx तो है, डिनोमिनेटर 1 plus x to the power. ठीक है, इसको हम क्या लिख सकते हैं, बीटा पी क्यू इक्वल टू 0 to 1, you just add it, x to the power p plus q, this will be x to the power p minus 1 plus x to the power q minus 1 dx, hence proved. ओके इतना तो प्रूव करना चाहिए था, करना था ना. वी नीड टू प्रूव दिस मच बीटा दिस वन x to the power p minus 1 x to the power q minus 1 x to the power p minus 1 q minus. Okay, okay, okay. Now we are going to go for our next question, question number 3. The question number 3 is given that evaluate this integral, that is your 0 to infinite integration limit t to the power 3 plus t to the power 8 by 1 plus t to the power 13 dt. This integral can be evaluated by using this form of the beta function, this one, the so-called first form what we have been discussed, that is your beta pq equal to 0 to infinity t to the power p minus 1 by 1 plus t to the power p plus q dt. Okay, how it is, you just watch. Okay, solution. The given integral can be written as what is equal to 0 to infinity. Just I'm going to segregate by two integrals, t cube by 1 plus t to the power 13 dt plus another integral, that is your 0 to infinity t to the power 8 by 1 plus t to the power 1 by 3 13 into dt. Okay, is equal to 0 to infinity. Here t to the power 3 can be written as 4 minus 1, 3 can be written as 4 minus 1 by 1 plus t to the power, this 13 can be written as 4 plus 9 dt. Similarly, second integral can be written as t to the power 8. 8 can be written as 9 minus 1 by 1 plus t to the power 13 can be written as 9 plus 4 dt. Okay, let this is your equation number 1. Now consider this one, that is your beta pq. What we know, 0 to infinity, we know this one, 0 to infinity t to the power p minus 1 by 1 plus t to the power p plus q dt. Let this is your equation number 2. Now compare equation number 2 with this integral and with this integral. First I am going to compare with this integral. Here you can see t to the power p minus q 1 plus t to the power p plus q. If I am going to compare with this integral, here p is nothing but your 4, q is nothing but 9. So if this integral is written as beta pq, then this integral will be beta 4 9, right? Likewise, if I am going to compare this integral with this one, then this integral will be written as beta 9 4, right? Because here instead of p 9 is there, instead of q 4 is there, so beta 9 4 we can write, right? So same thing I'm writing over here, comparing equation number 2 and 1. The equation 1 will be कितना होगा, इज इक्वल टू इंटीग्रेशन, सॉरी डायरेक्ट मैं लिखता हूँ, डायरेक्ट इज इक्वल टू बीटा is equal to beta 4 9 plus this one, for this integral second integral 9 4, right? Okay, is equal to beta, here I am writing beta 49 plus beta 94 can be written as also 49 by using symmetry property, by using symmetry property. symmetry property क्या था? बीटा पी क्यू इज इक्वल टू बीटा क्यू पी. Okay, so by using symmetry property we can write beta 94 equal to beta 49, right? Now is equal to, here you can see beta 49 plus beta 49, it will be 2 beta 49. Now we are going to use the relation between beta and gamma function. Then beta 49 can be written as gamma 4 into gamma 9 by gamma 4 plus 9. Here you just write by using a relation between beta and gamma function. That is what we know, that is your beta pq equal to gamma p into gamma q by gamma p plus q. So here p is your 4, q is your 9, is equal to 2 into, here gamma 4 is nothing but 3 factorial, into gamma 9 is nothing but 8 factorial. Here gamma 9 plus 4, 13. 13 means it will be 12 factorial, is equal to 2 into 3 factorial is nothing but 6, into 8 factorial को रहने दो इधर. 12 factorial can be written as 12 into 11 into 10 into 9 into 8 factorial. 8 factorial, 8 factorial got cancelled. Here 2 into 6, 12 got cancelled. Finally what we get the answer, finally हमको मिला कितना, 9 into 11, 99, 10, 990 is your answer. The final answer of this question is this one. Okay, now we are going to go for our next question. Next question, that is your question number 4. Given that we have to evaluate this integral, that is your 0 to pi by 2 limits root over of tan theta d theta. See here, this is a trigonometric function. So this question will be solved by using trigonometric form of beta function, this one. Last class we have been proved that one also. Here, this one, this is your trigonometric form of beta function. We are going to use this form of beta function to solve the question number 4. Okay, so let's start. पहले मैं वो ट्रिगोनोमेट्रिक फॉर्म को यहाँ पे लिख देता हूँ, ठीक है. सॉल्यूशन स्टार्ट्स. वी नो द ट्रिगोनोमेट्रिक form of beta function is what? Beta pq is equal to 2 into 0 to pi by 2 sine to the power 2p minus 1 theta into cos to the power 2q minus 1 theta d theta, or this can be written as 0 to pi by 2 sine to the power 2p minus 1 theta into cos to the power 2q minus 1 theta d theta is equal to beta pq by 2. इक्वेशन नंबर 1 देके रखो. Let this is your equation number 1. Now consider the integral whatever given in the question. Now consider the given integral. Consider the given integral. Given integral in question. That is your that is 0 to pi by 2 root over of tan theta d theta is equal to 0 to pi by 2. This tan theta root over can be written as what? Sine to the power 1 by 2 theta cos to the power minus 1 by 2 theta d theta. Here sin theta by cos theta. So obviously sin का पावर कितना रहेगा? प्लस हाफ, cos का पावर माइनस हाफ. ठीक है. Now we are trying to write this integral in this format. If we can write, then directly we can apply the beta function, right? So here consider 2p minus 1 equal to 1 by 2 and 2q minus 1 equal to minus 1 by 2. That implies 2p will be 1 by 2 plus 1, 3 by 2, and p will be equal to 3 by 4. Similarly, 2q will be equal to 1 by 2 and q will be equal to 1 by 4. Okay. So here 1 by 2 and minus 1 by 2 can be written like this, 2p minus 1 and 2q minus 1. So इसको एक इक्वेशन नंबर दे दो, इक्वेशन नंबर 2. दैट इम्प्लाइज इक्वेशन नंबर 2, hence equation number 2 will be what we can write, 0 to pi by 2 root over of tan theta d theta will be equal to 0 to pi by 2 sine, instead of 1 by 2 we can write to p minus 1 format. That means instead of p we can write 3 by 2, 2 into 3 by 2 minus 1 theta cos 2 into 1 by 4 minus 1 theta d theta. Let this is your equation number 3. Now compare RHS of equation number 3 and LHS of equation number 1. Here this one and this one I am writing here. Compare. Now by comparing that लिख देता हूँ. Now comparing RHS of equation number 3 and LHS of equation number 1, we get, carefully you just watch. Here I am comparing the RHS of equation number 3 and LHS of equation number 1. Here sin theta power कितना है? 2p minus 1, cos theta power 2q minus 1, and we have the answer is your beta pq by 2, right? Here 2 into 3 pi by 4 minus 1, here 2 into 1 by 4 minus 1 d theta. So here this is treated as P, this is your Q. If I will be compare equation number 3, RHS of equation number 3 and LHS of equation number 1. If it is so, अगर ये है तो ये इंटीग्रल का वैल्यू कितना हो जाएगा, ये हो जाएगा बीटा 3/4 1/4, right? Same thing I am going to write. Now by comparing RHS of equation number 3 and LHS of equation number 1, we get what? That implies we get 0 to pi/2 root over of tan theta d theta will be equal to, here this integral will be beta 3/2 3/4 1/4 instead of beta pq, and by 2 also we have to write. Okay, so this integral value will be this much by 2 also. Okay, this will be beta 3/4 1/4 by 2. Now we are going to simplify it. That implies 0 to pi/2 root over of tan theta d theta 1/2. I'm going to use the relation between beta function and gamma function. Beta pq is nothing but gamma p into gamma q by gamma p plus q, like that. Here gamma 3/4 into gamma 1/4 by gamma 3/4 plus 1/4, right, is equal to 1/2. This can be written as gamma 1/4 into gamma 3/4 can be written as 1 minus 1/4, right, by here 3/4 4 plus 1/4 is nothing but your gamma 1, right. That implies 0 to pi/2 root over of tan theta d theta will be equal to 1/2. Here gamma 1 is your 1, we know this value already we have been proved this type of things. तो इसका वैल्यू मैं पहले लिख देता हूँ. Gamma 1/4 into gamma 1 minus 1/4 will be equal to pi by sine pi/4. Why? Because we know that what, gamma n into gamma 1 minus n is equal to pi by sine n pi. Okay, so here n is how much, 1/4. So if it is so, pi by sine n pi, n means 1/4 into pi, so pi/4. So finally how much we got? Answer tan theta d theta 1/2 into sine pi/4 value is your 1/√2. so √2 तो ऊपर चला जाएगा, √2 into pi will be equal to pi by √2 is your final answer. Okay, now we are going to go for our next question. Our next question is the question number 5. Here we have to evaluate this integral. Here two integrals are multiplied with each other. So first integral is your 0 to 1 t square by whole root over of 1 minus t to the power 4 dt into another integral is your 0 to 1 integration limits dt by whole root over of 1 plus e to the power 4. Here 1 minus and here 1 plus. This integral or this question will be solved by using trigonometric form of beta function. Okay, so first I am writing the trigonometric form of beta function, then we are going to solve this question. Okay, the trigonometric form of beta function is what we know, that is your beta pq is equal to 2 into 0 to pi by 2 sine to the power 2p minus 1 theta into cos 2q minus 1 theta d theta, or we can write 0 to pi by 2 sine to the power 2p minus 1 theta into cos 2q minus 1 theta d theta is equal to beta pq by 2. Let this is your equation number 1. Here in the question we have two integrals, both are multiplied with each other. Let this is your I1 first integral and this one is your second integral, that is your I2. So to evaluate the question number 5, that means we have to evaluate I1 and I2 separately, and finally we are going to multiply. Okay, so first we are going to evaluate I1 value. So put a small heading over here, evaluate I1, which is equal to how much? 0 to 1 t to the power 2 by whole root over of 1 minus t to the power 4 dt. This integral I1 will be evaluated using trigonometric function or trigonometric form of beta function, whatever I have been written in the equation number 1. So to do so, here I am going to substitute, let t equal to t square. I am going to substitute t square as your sine theta. So that implies 2t dt will be equal to cos theta d theta, and here if t square is your sine theta, then t will be root over of sine theta, right? That implies dt will be equal to cos theta by 2t into d theta. That implies dt, finally what we can found, cos theta by 2 into t. T value is how much? Root over of sine theta. Here you just write that one, root over of sine theta d theta. So dt value we found this one, this much. Then we are going to consider the new limit. Here you can see we considered t square equal to sine theta or t equal to root over of sine theta. So when t approaches to 0 or t equal to 0, here if I am going to put t equal to 0, because 0 is the lower limit. When t equal to 0, then theta at that time has to 0, because if t equal to 0, theta will be sine inverse t, or you can simply you can put sine 0 equal to 0. When t approaches to 1, because upper limit is your 1, when t approaches to 1, then theta will be pi by 2, because here if I will put pi by 2, sine pi by 2 is your 1. So limit will be changed from 0 to pi by 2 for this integral. Okay, you just consider this is your equation number 2, it will be better. Now the equation number 2 will be, now equation number 2 will be how much? That implies I1 will be equal to, here the limit will be changed from 0 to pi by 2. Initially it was 0 to 1, now it will be 0 to pi by 2, right? Instead of t square we have to substitute what? Sine theta divided by, here I am going to write directly, here we consider t square equal to sine theta. So here 1 minus t to the power 4 root over, here if I will put t square, so it will be 1 minus t square equal to sine theta, it will be 1 minus sine square theta root over, that will be cos theta. So the denominator will be cos theta into dt, we have to write what? Cos theta by 2 into root over of sine theta d theta. Okay, okay, here cos theta got cancelled, and we found that implies I1 equal to 1 by 2 taken outside of this integration, because it is constant. 0 to pi by 2 cos theta got cancel here, root over sin theta. So we finally we found what? Sin theta to the power 1 by 2 d theta. Okay, and here this integral I1 also can be written in this format, that like this, 0 to pi by 2 here, sin पावर कितना है, हाफ थीटा इंटू कॉस का पावर मैं लिख देता हूँ 0 थीटा डी थीटा, because cos 0 theta is nothing but 1. So here 1 is there. So instead of 1, we can write cos power 0 theta d theta, right? That implies I1 will be equal to 1 by 2, 0 to pi by 2 sine, here 1 by 2, 1 by 2 can be written in the format of 2p minus 1. If I'm going to write in this format, then p will be how much? P will be 3 by 2, sorry 3 by 4. P will be 3 by 4. Already this type of things already we have been done in our previous question. If I will put 3 by 4 over here, this will be 3 by 2 minus 1. 3 by 2 minus 1 means it will be 1 by 2, right? So here this 1 by 2 साइन का पावर यहाँ पे जो 1 by 2 है, इसको मैं क्या लिख सकता हूँ? 2 into 3 by 4 minus 1, ओके, इंटू कॉस का पावर कितना है? 0. ये 0 को मैं क्या लिख सकता हूँ? 2q माइनस 1, ऐसे फॉर्मेट में अगर लिखना चाहूँ तो क्या लिख सकता हूँ? 2 इंटू 1 by 2 माइनस 1, ये 2 गॉट कैंसिल, 1 minus 1 0. सो हियर 0 कॉस 0 थीटा, और कॉस का पावर जो 0 है उसको मैं क्या लिख सकता हूँ? देखो 2 इंटू 1 by 2 minus 1 theta d theta, right? Here I directly written these things, p value and q value, but in our previous question, may you have been remembered, I evaluated that one like this. You can evaluate or you can write directly, no problem. Okay, so here we found this one. Let this is your equation number 3. Now by comparing equation number 3 and 1, now by comparing equation number 3 and 1, we get, here you can see, here this is your equation number 1, this is your equation number 3. here यहाँ पे साइन का पावर कितना है? 2p माइनस 1, कॉस का पावर 2q माइनस 1. यहाँ पे साइन का पावर कितना है? 2 इंटू 3 by 4, cos का पावर 2 into 1 by 2. So if I am going to compare this one, this integral in your equation number 3 with this integral of equation number 1, then what we can found? P is your 3 by 4 and Q is your 1 by 2. So in your equation number 1, this integral value is your how much? Beta PQ by 2. So by comparing equation number 1 and 2, this integral value will be how much? Beta 3 by 4, 1 by 2 by 2. Okay, same thing I'm going to write over here. So by comparing equation number 3 and 1, we can write over here as that implies I1 will be equal to 1 by 2 into beta 3 by 4, 1 by 2 by 2. This will be equal to 1 by 4 into, we are going to use here relation between beta and gamma function. Beta 3 by 4, 1 by 2 will be written as gamma 3 by 4 into gamma 1 by 2. This is 1 by 2, 1 by 2 by gamma 3 by 4 plus 1 by 2. Finally, what we can get? 1 by 4. Here gamma 3 by 4 I written as such. Gamma 1 by 2 is your root pi by this one will be 3 by 4 plus 1 by 2. the value will be 5 by 4, gamma 5 by 4. So this much answer we found. Let this is your equation number 4, right? Now we are going to evaluate I2 integral. Simply put a heading, evaluate I2. I2 हमारा क्या था, 0 to 1 dt by root over of dt by whole root over of 1 plus t to the power 4, 1 plus t to the power 4, इतना ही था, ठीक है। इसको भी हम वही ट्रिगोनोमेट्रिक फॉर्म ऑफ बीटा फंक्शन यूज करते हुए इसको इवैल्यूएशन करेंगे, ठीक है। सो टू इवैल्यूएट दिस I2, let us consider t square equal to tan theta. So t कितना हो जाएगा, रूट ओवर ऑफ tan theta. Here if t square equal to tan theta, then 2t dt, differentiating both the side, it will be 2t dt derivative of tan theta with respect to theta is your sec square theta d theta. That implies dt will be sec square theta by 2t d theta. Here t value we found root over of tan theta. I am going to substitute over here. Then dt we found sec square theta by 2 into root over of tan theta d theta. So here we found dt value. Now we are going to check the limit. लिमिट यहाँ पे नया लिमिट क्या हो सकता है और क्या हो रहा है, तो हियर t इक्वल टू root over of tan theta or t square equal to tan theta. For t, the lower limit was 0, upper limit 1. So for t equal to 0, theta will be equal to how much here? If I am going to put 0 over here, see, sin theta by cos theta equal to tan theta. So if I am going to consider theta equal to 0 over here, so it will be 0. So tan theta also will be 0. So for theta equal to 0, here tan theta will be 0. Then it has been satisfied that for t equal to 0, theta also has to 0. For t equal to 1, that means when t approaches to 1, upper limit 1 approaches to 1, theta approaches to what? Here you can see we consider t square equal to tan theta. So if t square equal to tan theta and t approaches to 1, here theta has to approaches to pi by 4, because we know that tan pi by 4 equal to 1. Okay, so theta will be pi by 4. See, इसको हम ऐसे भी कर सकते हैं कि tan theta will be 1, theta will be tan inverse 1, tan inverse 1 is nothing but pi by 4. So कोई जरूरत नहीं है यहाँ पे, not required. So here we found the limits are changed. Initially it was 0 to 1, now it will be 0 to pi by 4, नया लिमिट. सो इसको हम एक इक्वेशन का नाम दे देते हैं. लेट दिस इज योर इक्वेशन नंबर 5. नाउ इक्वेशन नंबर 5 विल बी, इक्वेशन नंबर 5 क्या होगा अभी. नाउ इक्वेशन 5 विल बी, जो वैल्यू यहाँ पे हमको मिला है सबको यहाँ वहाँ पे हम सब्स्टिट्यूट कर देंगे. 0 टू ये हो जाएगा पाई बाई 4. ओके, डी टी का वैल्यू कितना है, सेक स्क्वायर थीटा होल डिवाइडेड बाय 2 इंटू रूट ओवर ऑफ tan theta into 1 by 1 plus e to the power 4, and we considered as here 1 plus t to the power 4. If t we are going to consider t square, I am going to consider tan theta, so ये वैल्यू कितना होगा 1 plus tan square theta root over will be sec theta. So directly I am going to write that 1 by sec theta d theta. Okay, okay, that implies I2 will be 0 to pi by 4. इसको थोड़ा सा सॉल्व कर दो. यहाँ पे 1 by 2 को बाहर ले लो, ये कांस्टेंट तो है. sec थीटा थे sec 1 sec थीटा will be got cancel. So sec थीटा by here sin थीटा tan थीटा रूट ओवर ऑफ tan थीटा है, इसको मैं लिख सकता हूँ क्या, रूट ओवर ऑफ sin थीटा into रूट ओवर ऑफ cos थीटा d थीटा, right? That implies I2 will be equal to 1 by 2 0 to pi by 4. Here you can see sec theta can be written as 1 by cos theta into 1 by root over of sin theta into root over of cos theta d theta. Okay, then see here I am doing each and every step. In your exam you can omit the steps. 0 to pi by 4. Here 1 cos theta root over of cos theta, if it will be cancelled out, then it will be root over of sin theta into root over of cos theta d theta, right? This can be written as is equal to 1 by 2 0 to pi by 4. Here I am going to multiply root 2 with denominator and numerator. Root 2 by here 2 into sin theta into cos theta whole root over d theta, right? That implies I2 we got 1 by 2 0 to pi by 4. रूट 2 को भी बाहर ले लो, अगर रूट 2 को मैं बाहर ले लूँ तो ये हो जाएगा 1 by रूट 2. ओके, हियर 2 रूट 2 गॉट कैंसिल, सो 1 by रूट 2 d theta by we can found here 2 sin theta cos theta is nothing but sin 2 theta root over, or we can write 1 by root 2 0 to pi by 4 is the limit. Here पावर इज 1 by 2, अगर वो न्यूमरेटर को चला जाएगा तो ये हो जाएगा कितना, साइन टू द पावर -1 by 2 2 theta d theta. Okay, that implies I2 will be equal to 1 by root 2 0 to pi by 4 sin to the power -1 by 2 2 theta into cos 0 2 theta d theta, ऐसे मैं लिख सकता हूँ. Okay, now if I am going to compare this integral with our trigonometric form of beta function, here this one sin theta cos theta format में तो है, it is in the form of sin theta cos theta, but the limit is pi 0 to pi by 4, but we need the limit 0 to pi by 2. 0 to pi by 2 होगा तो मैं बीटा फंक्शन का ये जो फॉर्मूला अप्लाई कर सकता हूँ. आई कैन अप्लाई दिस फॉर्मूला, अदरवाइज आई कुड नॉट. सो आई हैव टू राइट दिस integral limits as 0 to pi by 2. Then what I am going to do here, to do so let us consider 2 theta equal to phi. That implies theta equal to phi by 2. That implies d theta will be equal to d phi by 2. Okay, okay, now check the limit. For theta equal to 0, phi will be how much? Here you can see if theta will be 0, phi also 0. For theta equal to pi by 4, phi will be equal to how much? Here I am going to if I am going to substitute theta equal to pi by 4, then phi will be pi by 2. Okay, so the new limits are 0 lower limit, upper limit pi by 2. So here इसको एक इक्वेशन का नाम दे देते हैं. दिस इज योर इक्वेशन नंबर 6. now the equation number 6 will be, now equation 6 will be, that implies I2 will be equal to 1 by root 2, ये तो है, 0 to pi by 2 is the new limits. Sin to the power -1 by 2, here instead of 2 theta we have to write phi into cos to the power 0 phi, instead of d theta we have to write d phi by Okay, that implies I2 will be equal to, here 2 taken outside of this integral, 2 root 2, 0 to pi by 2, here minus pi, sorry, minus 1 by 2. See here, after taking this 1 by 2 outside of this integration, then compare the integral, this integral with, ठीक है मैं लिख देता हूँ, इन डिटेल लिख देता हूँ, एग्जाम में वो स्टेप you have to omit. Okay, this will be 1 by 2 phi cos 0 phi d phi. इसको एक इक्वेशन नंबर दे दो, इक्वेशन नंबर, लेट दिस इज योर इक्वेशन नंबर 7. नाउ कंपेयरिंग, नाउ नहीं, इसको फिर से हम लिख सकते हैं ऐसे, we have to apply the trigonometric form, no? So what we have to do, 1 by 2 root 2, okay, 0 to pi by 2 sine, here see, minus 1 by 2 I want to write in this format, 2p minus 1. So if it is so, then p will be how much? Here p will be minus 1 इधर आ जाएगा, ये हो जाएगा, 2p will be equal to 1 by 2, p will be 1 by 4. So minus 1 by 2 can be written as 2 into 1 by 4 minus 1. Here you can see it will be how much? 1 by 2, 1 by 2 minus 1 is your minus 1 by 2. Then cos 0, cos 0 can be written as 2 into 1 by 2 minus 1. Here sin phi, I forgot to write, phi cos phi d phi. इसको इक्वेशन नंबर 7 दे दो, इसको इक्वेशन नंबर 7 दे दो. This is your equation number 7. Now compare equation number 7 with 1 by comparing 7 and equation number 1. We get, here you can see equation number 1. In equation number 1, 0 to pi by 2. In equation number 7 also 0 to pi by 2 limit is there. Here 2p minus 1 theta cos 2q minus 1 theta d theta equal to beta pq by 2. Here in equation number 7 we have exactly same format, 0 to pi by 2. Here sine to the power 2, here 1 by 4 is nothing but your p, 1 by 4 is nothing but your p, right? Here p value is your how much? 1 by 4. Okay, comparing with equation number 1, q is your 1 by 2. So what will the value of this integral? The value of this integral will be beta 1 by 4 1 by 2 by, okay. So here directly what we are going to write, we have to write by comparing equation number 7 and 1, we get, that implies I2 will be equal to 1 by 2 root 2 into beta 1 by 4 1 by 2 by 2, or we can get 1 by 4 root 2. This will be equal to, by using relation between beta and gamma function, it will be gamma 1 by 4 into gamma 1 by 2 by gamma 1 by 4 plus 1 by 2. So finally how much we got? That implies I2 will be equal to 1 by 4 root 2 into gamma 1 by 4, gamma half is your root pi, by here gamma 1 by 2 plus gamma 1 by 4 plus 1 by 2, it will be gamma 3 by 4. Here I2 value, finally we found this much. Okay, finally we found this one. This much I1 we found in your equation number 4, and let this is your equation number 8. Now final answer will be, now final answer will be कितना होगा, I1 into I2, which will be equal to I1, here it has been written in equation number 4, 1 by 4 gamma 3 by 4 into root pi by gamma 5 by 4, 1 by 4 into gamma 3 by 4 by gamma 5 by 4 into root pi. This is your I1 value. I2 value here in equation number 8 we found, that is your 1 by 4 root 2 into gamma 1 by 4 into root pi by gamma 3 by 4. This is your I2 value. So just to simplify, here gamma 3 by 4 got cancel. Okay, here root pi will be pi, and here 4 16, so 1 by 16 root 2 into root pi into gamma 1 by 4 by gamma 5 by 4 can be written as what? 1 by 4 plus 1, right? So here it will be 1 by 16 root 2 into root pi into gamma 1 by 4 by, here we are going to use first property, that is your gamma n plus 1 is your n gamma n. It will be 1 by 4 into gamma 1 by 4. So finally what we got here, gamma 1 by 4 gamma 1 by 4 got cancelled. Here 4 16, if I'm going to divide, finally we found root pi by 4 root 2 is the answer. Okay, see here we have been discussed this question in detail stepwise, but I suggest to all of you that you just practice it, and in your exam you can omit your steps. Okay, now we are going to go for our next question. Our next question is your question number 6. We have to evaluate this integral. The integral limits are -1 to +1, 1 plus x by 1 minus x whole root over dx. This integral can be solved by using trigonometric form of beta function. So let's start to solve it. Solution. To solve or to evaluate this integral, let us consider x equal to cos 2 theta. Dx will be minus sin 2 theta into 2 d theta. Now we are going to check the limit. Initial limit was -1 to +1. So if I am going to substitute x equal to cos 2 theta, then new limit क्या होता है ये हम यहाँ पे देख लेते हैं. For x equal to -1, यहाँ पे अगर मैं x equal to -1 consider करूँ, और when x will be approach to -1, then theta will be approach what? Here I'm going to explain. See, if I'll put theta here pi by 2, then this will be cos 2 into pi by 2, or cos pi will be -1, so theta will be pi by 2. For x equal to +1, because upper limit कितना है? +1. Here if we are going to consider x equal to +1, theta will be equal to, here you can see, for x equal to +1, cos either 0 or 2 pi or 4 pi like that, but here it will be 0, because we know that gamma function and beta function exist in the first quadrant. Okay, so theta varies from 0 to pi. Here new limit we found pi by 2 to 0. Okay, now the above integral will be the above integral will be कितना हो जाएगा? अभी लिमिट कहाँ से कहाँ तक होगा? लोअर लिमिट इज योर पाई बाय 2 to upper limit 0. Here instead of x we have to substitute cos 2 theta. So 1 plus cos 2 theta by 1 minus cos 2 theta whole root over into, instead of dx we have to substitute this value, minus sin 2 theta into 2 into d theta. Okay, here if I'm going to consider minus 1 is going to be interact with this integration, then the limit will be altered. So it will be 0 to pi by 2. Here 2 is a constant taken outside of this integration. Due to minus sign, this limit changed. Okay, and here this can be written as, here 1 plus cos 2 theta is nothing but 2 cos square theta, 2 cos square theta. 1 minus cos 2 theta is your 2 sin square theta whole root over sin 2 theta can be written as 2 sin theta into cos theta d theta is equal to, this 2 taken outside of this integration, it will be 4, 0 to pi by 2. Here you can see, here root 2 got cancel. Here cos square theta root over cos theta, sin square theta root over sin theta, here 1 sin theta got cancel, and finally we found cos square theta d theta. Here after root over of this cos square theta, it will be, we can find cos theta, यहाँ पे cos theta है कितना हो जाएगा cos square theta. तो अभी इस इंटीग्रल को मैं ऐसे भी लिख सकता हूँ, 0 to pi by 2 साइन का पावर 0 थीटा into cos square theta d theta, because instead of 1 we can write sin 0 theta, sin power 0, okay, power 0 theta cos square theta d theta. This can be written as 0 to pi by 2. Here sin 0 को मैं क्या लिख सकता हूँ, in this format, 2 into 1 by 2 minus 1 theta. Here 2 got cancel, 1 minus 1 0. This cos square theta, here power 2 can be written as, here can be written as in this format, 2 into 3 by 2 minus 1 theta d theta. Here 2 got cancel, 3 minus 1 is your 2. Okay, this is your 2. अच्छी तरह से लिख देता हूँ. Okay, now this integral I am going to compare with trigonometric form of beta function. Here we just put a equation number for this one, equation number 1. Now consider trigonometric form of beta function. What is that? 0 to pi by 2 sin 2t minus 1 theta into cos 2 cube minus 1 theta d theta is your beta pq by 2. Equation number 2. Now just compare equation number 1 and 2. What we can find here, 0 to pi by 2, 0 to pi by 2, integration limits are same. Here sin theta to the power 2p minus 1, here 2 into 1 by 2 minus 1. So here this is nothing but your p. Here 2q minus 1, here 2 into 3 by 2, this is nothing but your q. If this integral value is your beta pq by 2, then this integral value will be how much? Beta 1 by 2, 3 by 2 by 2. Same thing I am going to write over here. Now considering trigonometric form of beta function, this one, now comparing equation number 1 and 2, the value of equation number 1 will be, the value of equation number 1 will be कितना होगा? That implies 4, 0 to pi by 2 sin to the power 2 into 1 by 2 minus 1 theta into cos to the power 2 into 3 by 2 minus 1 theta d theta will be equal to कितना हो जाएगा? 4 into ये जो इंटीग्रल का वैल्यू कितना हो जाएगा? बीटा 1 by 2, 3 by 2 by 2. Okay, so is equal to, here 4 by 2 is your 2. Here I am going to use the relation between beta and gamma function. Then this will be gamma 1 by 2, gamma 3 by 2 by gamma 1 by 2 plus 3 by 2, which will be equal to 2 into gamma 3 by 2 can be written as gamma 1 by 2 plus 1. Gamma half is your root pi by gamma, this will be how much? This will be 4 by 2. 4 by 2 is your gamma 2. We found how much? 2 into here. if I'm going to use the first property of gamma function, gamma n plus 1 is nothing but gamma n. So this will be half into gamma half into root pi by gamma 2 is nothing but 1 factorial 1. Finally, we found the answer. How much here? 2 got cancelled, and here gamma half is a root pi. So root pi into root pi equal to pi is our final answer. Okay. Here we are going to stop our discussion of this class. In this class, we have been discussed questions belongs to your beta function based upon definition of the beta function and different forms here based upon definition and this form of the beta function and trigonometric form of beta function. In our next class, we are going to discuss some questions, some important questions which are based upon these two properties. Okay, so thank you so much for watching this video. Thank you.